everyone, Mrs. Patel Dane here with topic 7.12, the common ion effect. So pretty much what happens here is that we're taking a solution and adding an extra ion into that solution. And so we're trying to figure out what happens with equilibrium and what shifts essentially. So here's a practice problem from the last topic. We have barium sulfate solid dissolving into barium plus 2 ions and sulfate ions. And so we just want to figure out what the concentration of barium and sulfate ions are in the reaction given that KSP. So go ahead and pause and do this problem. All right, so again, like we've seen in the last topic, we take our rice table. So we have barium sulfate, and again, producing barium ions and sulfate ions. Now, as you've probably seen, you most likely you pretty much don't need to do the rice table when it comes to KSP problems, but the point is I want to show you what happens when we kind of shift equilibrium. So if you can get away with outdoing that rice problem or rice table for just a straight up KSP, that's fine. But for the rest of this topic, we're going to go ahead and do them. So again, barium sulfate's a solid. We don't include that in our equilibrium expression. So we have KSP is equal to barium plus 2 and sulfate, SO4 minus 2. Plugging them in, we have 1.07 times 10 to the negative 10th for the KSP and x squared for your ions. So we just take the square root of that. And again, I can't stress enough when it comes to the AP exam, make sure you know your calculator really, really well. So here we have 1.03 times 10 to the negative 5th. Remember, we need to have 3 sig figs because that's what we have for our original KSP. And so that's how many barium ions you have and sulfate ions you have. And one thing to note in here, do make sure that you have an equal sign. So we want to make sure that you see that it's the barium plus 2 is equal to the sulfate. That the drawing itself doesn't have that. Sorry about that. But again, make sure you have an equal sign between the two. So we're going to see what happens when you add extra sulfate ions into the solution. So according to Le Chatelier's principle, what happens to equilibrium if sulfate ions are added to this reaction? Now again, anytime you see Le Chatelier's principle, think about your seesaw and what might happen with that. So go ahead and pause and think. All right, so if we're going to add more sulfate ions, essentially think about adding a child on the seesaw on that side. What's going to happen? Well, that side's going to go down. The equilibrium is going to favor or shift towards the reactant. So it's going to favor the reactants. So we're going to kind of favor the reverse reaction here. Not only will that right-hand side go down, but we also want to make sure we think about this. If we have more sulfate ions, your barium ions are going to be consumed as well. So we should have a smaller number of barium ions at the end. So we're going to, again, favor that reverse direction. So let's think about this mathematically and what might happen. So in this case, we have 0.10 molar of sodium sulfate ions that are added into here. So pause, set up your rice table, and we'll meet back up. All right, so in here we have sodium sulfate. Now, it's going to break up into 2 Na plus ions and then 1 sulfate ion as well. So we want to make sure we realize what's actually happening in here. So like I said before, if it's just a straight up solubility product question, you don't necessarily need the rice table. But here, this is not a straight up question. We're shifting or changing something. So we're going to go back and put these things into the rice table that we need. So again, for barium sulfate, since it's a solid, it is negligible. And this is where we change things up. So since we have additional sulfate ions, we're going to add that into the change for the sulfate ion. The barium ion, of course, stays the same for right now, and we're going to see what happens with that. So we're going to do exactly what we did before with the rice table and setting up your KSP. So again, KSP is equal to the barium ion times your sulfate ion. And again, don't forget on your AP exam to make sure you show this. Your AP readers are seeing that you know how to set up a simple equilibrium expression. You might even get a point for that too. And that's a pretty easy point to get, but that'd be pretty bad if you didn't put that stuff in. So if you look at this algebraically, it looks as if we would kind of have a quadratic equation that we'd have to solve for. Again, on your AP for your responses, you're not expected to solve using the quadratic equation. So think through, okay, if you see yourself doing FOIL and all that sort of stuff, look back to your KSP value. it's pretty small, right? It's less than times 10 to the negative fourth. So you can assume that the X is negligible in that sulfate ion. And then you would, of course, just solve mathematically. Now, if this were multiple choice where you didn't have a calculator, we want you to think through. When you have times 10 to the negative 10th divided by a decimal, well, think about that decimal as 1.0 times 10 to the negative 1. When you divide scientific notation, you're essentially subtracting the exponent. So it's negative 10 minus a negative 1. That should give you a negative 9. So again, you wouldn't necessarily need your calculator for this part. So your answer for your barium ion is 1.07 times 10 to the negative 9th molar. Then we plug that back in to what we had for the sulfate. So it was X plus 0.10. And so you end up with 1.00 times 10 to the negative 1. Or if you just go ahead and put 0.10 molar as your answer. So here's another practice problem. So in this case, we have calcium fluoride, and we're adding 0.20 molar lithium fluoride. So go ahead and set up your rice table and solve. All right, so again, with our rice table, again, can't emphasize this enough. Make sure that you have this in there. And don't just try to plug right into your equilibrium expression, because your AP readers are looking to see that you know that that change will also include what's happening with your lithium fluoride. So again, with the solids, that's all negligible. You have 0 for your initial of both substances. Your calcium is just plus X. Now your fluoride, don't forget, since you have 2 fluorides, you have to have 2X. And then we're putting in the 0.20 molar. So we have 2X plus 0.20 molar for fluorine, or fluoride ion, sorry. Show your equilibrium expression, your calcium plus 2 ion times your fluoride minus 1 to the negative 2. Don't forget that that coefficient becomes the exponent as well. So we're going to plug in our values. And again, if you looked at this, it would look as if we would have to solve for a quadratic, and we don't do that on our AP free responses, which is really fortunate for you guys. So looking at your KSP value, it's times 10 to the negative 10th. It's really, really small. So you can assume that your X is going to be small for your fluorine or negligible. Again, you have to make sure that you write that. You can't just get rid of it without saying assume X is small or assume X is negligible. It has to be in there. Otherwise, again, you may not get credit for that. So you have X times 0.04. Don't forget that that 0.20 needed to be squared, right? So that's why you got your 0.04. We got rid of the 2X, but we still have to square that 0.20. So when we solve for this, we end up with 3.65 times 10 to the negative 9th molar. And again, that's for your calcium ions. And of course, we need 3 sig figs for this as well, because our KSP has 3 sig figs. So we're going to use the E value essentially for your fluorine and plug that in. And again, this is all the work that you want to show. And this is a good way to set it up too when you're thinking about it, because you have that whole span of paper if you need, and you can show this part over to the side. Make sure you show arrows so that way your reader knows where this information is coming from. So again, we're going to solve for that value, multiply your your molarity by 2, and then add in 0.20, which pretty much, since it's a large value compared to what you had for your calcium ion, it's going to be 2.00 times 10 to the negative 1, or 0.20. So again, this is your concentration for each one. One thing I would add here is make sure that you put brackets around that F minus. So again, your reader knows that it's your concentration as well, since you already have that for your calcium plus 2. Might as well put that in. All right, so again, at this point, hopefully you've seen that by adding in some ions, we're going to shift the equilibrium, and hopefully you know how to change that. Thank you very much for watching. Take